All right, welcome. Have you ever wondered how your computer magically finds your printer on the network? Or really how any of your devices manage to talk to each other? It seems like it just works, but underneath it all, there's this really simple but kind of elegant system. Today, we're going to peek under the hood at one of the most fundamental tools in networking, the ARP table.
Okay, so let's get right to the core problem we're trying to solve. Your computer knows the IP address of another device, right? But believe it or not, that's not actually enough to send it anything. See, the IP address is kind of like knowing someone's name, but to actually deliver a package, you need their physical street address. In the world of networking, that street address is called the MAC address. So how on earth does a device find the street address when all it has is a name?
Well, to answer that, we first have to get our heads around the fact that every device on your local network is basically bilingual. It speaks two languages. It uses IP addresses to know where a device is logically, like its neighborhood, and it uses MAC addresses for the actual physical delivery, the specific house on the block. The real trick is translating between the two.
And this, right here, is where our hero of the day comes in, the ARP table. The easiest way to think about it is just like an address book. Seriously. Every single device, your phone, your laptop, even your smart fridge, it keeps its own little private address book that helps it translate between those two languages, from IP address to MAC address.
Now, why is this so important? Well, without this address book, every single time your computer wanted to send the tiniest bit of information, it would have to shout out to the entire network, "Hey, who has this IP address?" Just imagine the chaos. It'd be like trying to have a conversation in a room where everyone is yelling all the time. The ARP table is what keeps the network calm and orderly.
So this address book sounds pretty essential, but it doesn't just appear out of nowhere. Let's get into the nuts and bolts of how it's actually built and, just as importantly, how it's maintained.
Okay, so this address book basically has two different kinds of entries. Over on the left, you've got dynamic entries. These are the most common by far. They're created automatically as your devices chat with each other, and they're temporary. Then, on the right, you have static entries. These are the opposite. They're put in manually by a person, they're permanent, and they're usually reserved for really important things, like servers that never move.
For our purposes today, we're going to focus almost entirely on those dynamic entries, because honestly, that's how your network runs about 99% of the time. It's this beautiful, automatic, self-managing system that all revolves around something called an ARP request.
This slide just lays out the whole dance perfectly. Let's walk through it. First, PC1 wants to send something to an IP address, but it's missing that physical MAC address. So what does it do? Step 2, it broadcasts a message to everyone on the local network, basically shouting, "Hey, who owns this IP?" Every device hears it, but only PC2, the actual owner, responds. In step 3, PC2 sends a reply, but this time it's directly back to PC1, saying, "Hey, that's me. Here's my physical address." And finally, step 4, PC1 gets that info and jots it down in its address book. So simple, right? And incredibly efficient.
And boom! Here's what it looks like after that conversation. PC1's address book is now updated. You can see the IP address, the MAC address it just learned, and notice the type says dynamic. Now, for a while at least, PC1 knows exactly where to send data for PC2 without having to ask again.
But you see that dynamic label? That is a super important detail because it means that entry is not going to last forever. And that brings us to the life cycle of these entries, which is really the secret to what makes this whole system so clever.
So think of it like this. Every dynamic entry comes with a little countdown clock. As long as the two devices are talking back and forth, that clock keeps getting reset. But the moment they stop chatting, that clock starts ticking down. So if we look at our table again, as long as PC1 and PC2 are actively communicating, this entry is totally safe. But the second that conversation ends, its timer starts counting down to expiration.
And when that timer finally hits 0, poof, the entry is just wiped from the table. Now, that might sound like a bad thing, but it's actually a vital feature. Networks change all the time. What if PC2 gets a new network card or is replaced with a different machine? This aging process makes sure PC1 isn't trying to send data to a ghost.
So, what happens if PC1 needs to talk to PC2 again after the entry is gone? It's beautifully simple. The whole process just starts all over again from the top. PC1 shouts out its question, PC2 replies, and a brand new, totally up-to-date entry gets added to the table. This is what makes the system so brilliant. It's completely self-healing.
All right, so we've covered the mechanics, the how it works. Now let's connect all of this to the real world. Let's talk about why this actually matters for your network's performance and for, fixing things when they break.
So, when you put it all together, the ARP table is giving us three massive benefits. First, it keeps things efficient because devices don't have to shout for an address every single time. Second, that aging process we talked about makes sure the information is always fresh and accurate. And the result of those two things is the third benefit. It massively cuts down on all that noisy, unnecessary broadcast traffic.
And here's a fantastic pro tip for you. If you're ever pulling your hair out trying to connect to a printer or another computer on your network, the ARP table can be your best friend. It is often one of the very first places a network technician will look. For example, let's say you check your computer's ARP table and you see this. You're trying to reach the device at 192.168.1.50, but for some reason, your table has stored the wrong physical MAC address. Your data is literally being sent to the wrong house.
So what's the fix? Well, it's actually surprisingly simple. You can manually clear the ARP table. Basically, you're just wiping the slate clean. This forces your computer to forget what it thinks it knows and go out and ask for directions all over again the next time it tries to connect.
And after you clear it and try to connect again, this is what you get. The device relearns the correct MAC address, the table gets updated with accurate info, and just like that, your connection problem is solved.
So to wrap this all up, the ARP table is really one of those invisible workhorses of the digital world. It's just a simple address book, but it's also this powerful engine of translation that allows for efficient, accurate, and self-correcting communication on your local network.
We've totally nailed how devices talk to each other inside the local network. But what happens when a piece of data needs to go on a much, much bigger journey, out to the internet? How does ARP help it find the exit door? Well, that door is called the default gateway, and we'll explore exactly that in our next explainer. See you then.